Hello, this is Shakil Ahmed. In this tutorial, I would like to explain about the analysis of variance, that is one-way ANOVA. The analysis of variance is used to test whether three or more population means are equal or not. When we have two population means, we use uh, simple unpaired t-test when the two samples are independent. Are drawn from two independent populations, but the one-way is an extension of unpaired t-test when we have three or more subpopulations or groups. So the assumptions are the outcome variable should be quantitative, that should be at least at on uh, continuous scale or quantitative scale, and each group should be randomly selected and independent with each other. There should be no overlapping. The two groups should be independent, and each group data should follow normal distribution. That is another requirement, and variance of each group should be equal. So mostly these are the assumptions we need to uh, fulfill while applying an unpaired t-test. So here we have a null hypothesis that all means are equal, and the alternative hypothesis that at least one pair of mean is different from each other. You can say at least one mean is different from the any of the other mean. Then we will reject our null hypothesis. So whenever we are rejecting null hypothesis, it means that at least one mean is different from the other. So that's why when we reject our null hypothesis, we perform a post hoc test to test uh, which pairs are uh, different and which pairs are equal. So we are not sure which pairs are which two means are equal and which two are different. So we need to check uh, pairwise, and we can conclude that which pairs are equal and which pairs are different. So an investigator wants to compare the diastolic blood pressure among three treatment groups. We have diastolic blood pressure for patients in three treatment groups. Group A, Group B having 10 individuals, and Group C having 8 individuals. So we need to perform a analysis of variance to test whether there is a mean diastolic blood pressure is different or not in the three groups, three treatments. So we can write the sample sizes. For first group A, the sample size is 9. For group B, the sample size is 10. And for group C, the sample size is 8. And we can find the means as we have already the totals computed for each group. You can just divide it by this number, this, and then just enter, and you can just drag it. You will get the uh, population sample mean for the group 2 and the sample mean for group 3. And then the standard deviation, you need to find the standard deviation and variance as well. You can find standard deviation std dot sample, and this is for group 1, and you can find the standard deviation for group 2 B, treatment B, and sorry, I think I missed something. Standard deviation, that is C17 to C26, which is standard deviation as std dot it should be standard deviation, not only std, and then select the column. And for last one, you can again write the standard deviation s and the select the data. So these are the standard deviations, and you can see the standard means are three times the standard deviation. So we conclude that the data follows normal distribution. Although you can check using box plots, using other options as well. I have already, I think, already made a box plot here. If you can, if you want to see here, we can see that there is slightly deviation from normality. This is slightly positively skewed. This is also slightly positively skewed, but this is almost normal. So we proceed that the data follows a normal distribution. The three groups follow the normal distribution. You can find the variance. Just take square of the standard deviation. These are the variances, and the variances are different, although, but for uh, this calculation, we assume that the variances are equal, and we proceed with the analysis of variance. So first of all, we need to find the between sum of square, and then within sum of square, and then total sum of square. So we will perform first the total sum of square. For total sum of square, we need to find the deviation of each observation from the grand mean, and then square the deviations and sum overall the values. So these are the means. If you want to find the grand mean, you can just sum these three values. This is the total, and then you can divide. We have how many observations? I think we have 9 multiplied by 3. There are 27 observations. So this is the grand mean, if you want to write. And then we will find the deviations from the grand mean for each observation. We can start from here, and you can find the square of the deviations for your convenience, so that you don't need to uh, I am putting a dollar sign so that this value is will be fixed when we drag to the other values, and then square. So this is square of the first value from the grand mean, and then square. And you can just drag it to the first group consists of 9 observations, and you can drag it to group 3, and then you can drag into 10 observations. Here we have 8 observations. So we can find the sum, just sum it, and then select all these columns. The sum is 5562.59. This is the total sum of square. You can just write here 5, 6, 2, 1. And then we can find the between sum of square, or that is called the uh, treatment sum of square as well. So how we will find the between sum of square? So we have mean for each group. These are the means, and we can just find the between sum of square here as well. This is just we need to find the deviation from the total grand mean of these means, and that is just weighted by the sample size. The sample sizes are different. So I'm just finding n into the deviation and square. So what is the deviation? This is mean minus grand mean. What is the grand mean? That is 62.3. So you can just use E27 and fixed it. And you can square it and just multiply by this number. And you can drag to next two values. So these are the sum of deviations and multiply by the sample sizes, and you can just find the grand total. Uh, just sum it and drag. So this is 14. You can just copy it and then paste here, just value. And the within sum of square is total sum of square minus between sum of square. So this is the within sum of square, and we have three groups. So the degree of freedom is k minus 1, and here the degree of freedom is total. We have 27 observations, and the degree of freedom is 26, and then 26 minus 2, the degree of freedom is 24. And this is degree of freedom for the total, that is 27 minus 1, and this is degree of freedom for the between variation, and this is degree of freedom for within variation. And we can find the mean squares. Just divide the sum of square divide by the degrees of freedom, and you will get the mean square for be between groups. And similarly, you can find the mean square for within group, and then find the F statistic, that is the ratio of the mean square between and mean square error. So the ratio is exactly 4. And we need to just compare this value with the uh, tabulated value of F distribution. You can just find the F distribution. I think we need to set the probability, that is 0.95, and degree of freedom, we have two degrees of freedom, the numerator degree of freedom and the denominator degree of freedom, that is 3.4. So we can reject our null hypothesis that the tabulated value is less than the calculated value of the test statistic. So we reject H naught and conclude that there is the means, are the three treatment means are not equal, and we need to just perform a post hoc test in this case, as the three means are not equal. So in next video I will show how we can perform the case honestly significant different test that is called Turkey's HSD test for this case. Thank you.